Overfitting is a behavior that occurs when a model has high data accuracy at the time of learning as a result of having the model learn to follow the trend of data, but fails to have the same accuracy for unknown data in statistics and machine learning. Overfitting makes it difficult to actually operate the model. Overfitting occurs when a model learns specific data excessively. When the model is learning, overfitting needs to be prevented from occurring regarding the data, model, and learning method, while being aware of the occurrence of overfitting. To check for overfitting, the data used for learning is divided into training and test chunks. The training data is used to train the model, and the test data is used as pseudo-unknown data to evaluate the model. To evaluate a model, the evaluation index, such as discrepancy between predicted value and true value, is usually defined as an error, and the degree of application is evaluated numerically. Errors in learning with training data are called training errors, whereas those with test data are called generalization errors. Generally, the progress of learning is checked as a learning curve expressed by the number of training sessions and the error at that time. The error between the two gradually decreases in the early learning period. However, from a certain point, the training error continues to decrease, whereas the generalization error may increase. This indicates that the model is starting to overfit the training data, and performance on the unknown test data is starting to suffer. A very simple countermeasure is to stop learning this model and get a model with less overfitting. Some of the causes of overfitting include overfitting learning to non-essential noise-like data, in training data for prediction and classification, and trying to determine a large number of weighting factors from a small number of data. Once a tendency toward overfitting comes up, performance on unknown data starts to decrease. Here is a summary of specific instances of overfitting in terms of data, learning methods, and models. 1. There are many explanatory variables for the number of data. 2. Unknown data is not used, and unnecessary learning is prolonged. 3. Complex models are used for data. These overlapping causes can lead to a greater tendency of overfitting. Next, I will introduce some simple ways to deal with overfitting. 1. Adjust the number of data and explanatory variables. Overfitting can be prevented by eliminating information and items that are not needed as explanatory variables or features in learning beforehand, and reducing explanatory variables. 2. Terminate cross-validation and learning early. Splitting part of the data into test data to create pseudo-unknown data is the basis of overfitting. The way this division is done in multiple patterns so that different parts of the data become unknown data is called cross-validation. There are some cases where data is split in multiple pieces and is split in a more complicated way depending on the circumstance. If performance on the test data stops improving in the middle of learning, a model before overfitting can be obtained by stopping the learning. 3. Simplification of model. Overfitting can occur when a model is used that has a large number of parameters, or auxiliary variables, for the number of data items or items. It is required to reduce the complexity of the model by checking the overfitting situation while looking at the learning curve and so on. The first method is to reduce the model size by adjusting parameters. In tree models, the number of leaves and depth, etc., are adjusted to make them smaller to fit the size of the data. The second method is called regularization. By adding an effect, such as a penalty to the increase in the number of explanatory variables with a larger contribution to learn, explanatory variables are selected in the process of learning, and its number and contribution are reduced. As a result, the original algorithm has the effect of making the model smaller, and overfitting is avoided. The third is ensemble learning. By utilizing only a portion of the model or data during learning, this method creates many small models and integrates them as an ensemble. These include learning while disabling some units, and building models from randomly sampled data. Reducing the size of what is essentially a large model reduces complexity. The effectiveness of these methods of avoiding overfitting varies according to the data and the model conditions. Considering another model such as a simpler one is an alternative, and the approach must be considered on a case-to-case basis.